Good day, everyone. Today, we will be learning about trigonometric integrals, and the other one is integration by trigonometric substitution. So uh, in this problem, we are going to solve for different types of cases for trigonometric integrals. So there are two cases in powers of sine and cosine. So in powers of sine and cosine, case 1 is the integral of cosine of to the power of m of x times sine to the power of n of x dx, in which m or n, okay, take note of the word or, m or n is an odd number. So one of them, or one of the exponents of either m or n, if it's odd number, then we can use the identity sine squared plus cos x, or cos squared x is equal to 1, and then we are going to use what we have learned, which is the u substitution. So for example, in this situation, sine to the power of 4x cosine to the power of 7x. So here we can see that n here is an odd number, right? So n is an odd number, therefore we can consider this one as our case number 1. So this is odd number, this is case number 1. So therefore, according to this case, we are going to use the identity sine squared x plus cos squared x is equal to 1. How are we going to do that? Simple. What we're going to manipulate here is what is the the exponent that has the odd number. Therefore, we will manipulate cosine of 7x. So therefore, we can say that this is cosine squared x to the power of cube. Then we still have cosine x left. Okay, that's 3 times 2, that's 6, and then plus 1, that's 7x dx. So according to this case, we're going to use the identity. So cos squared x therefore is 1 minus sine squared x cosine of x dx. So what are we going to do here? According to this rule, once again, we are going to use the u substitution method. So what are we going to let u as so that we can integrate this uh, function? So that we are going to let u as sine x. Our du here is cosine of x dx. So if we are going to substitute, this is u to the power of 4 times 1 minus u squared. Cosine of x dx is du. So therefore, we can integrate this. So as you can see, you need to have the techniques on how you're going to integrate. What steps are you going to pursue in order for you to make this function kanang ma-integrate siya. So for this, you can now integrate this one since I forgot cube, sorry. So let us first, to integrate this one, let us first use the Pascal's triangle for this do. So let's start. I do not need to explain this since this was already discussed from your previous mathematics. But to give you a hint, there's a glimpse, this is 1, 2, 3. So the exponent here is 3, so we are going to use the coefficients 1, 3, 3, and 1. So therefore, in order for us to extract that, that's 1, okay, to the power of 3 minus 3, the coefficient 3, then times 1 squared times u squared to the power of 1, then plus again 3 times 1 to the power of 1 times u squared to the power of 2 minus 1 times 1 to the power of 0, and then u to the power of squared cube. So let's use bracket here. Okay, so you can also use 1 minus u squared, but it will take me time, no, to multiply this and this by using FOIL, and then the result of this and this multiply here. So you can use also that method. So therefore, to simplify that, that's u to the power of 4 times 1 minus 3u squared plus 3 to the power of 3u to the power of 4. So u squared times u squared is 4 minus 1 times 1 to the power of 6 is 1 u to the power of 6 dx. We forgot du rather. So we are going to distribute. That's u to the power of 4 minus 3u to the power of 6 plus 3u to the power of 8 minus u to the power of 10 du. So to integrate that one, this is u to the power of 5 over 5 minus 3u7 over 7 plus 3u9 over 9 minus u11 over 11 plus c. Okay, so therefore that can be written as, let's change u back to its original form, sine to the power of 5x all over 5 minus 3 sine 7x over 7. So this is 3 over 9 or 1/3 plus sine 9x over 3 minus sine 11x over 11 plus c. And that can be your final answer. You can also simplify that one, find the LCD, and then simplify. So that can be your final answer. So that is for case number 1. Alright, so for case number 2, this is its condition. So if both m and n is even number, then we are going to use the half angle identity if necessary. So for this example, sine squared x dx, remember that the half angle identity of sine squared x is just 1 minus cosine 2x all over 2, right? So if you're going to rewrite this one, that's the integral of 0 to pi over 2. That's 1/2 minus cosine 2x over 2 dx. Okay, therefore, that's from 0 to pi over 2, 1 over 2 dx minus from 0 to pi over 2. So that's 1/2 and cosine 2x dx. So to integrate 2x dx, that's u 2x. du is equal to 2 dx. Therefore, d over 2 is dx. So this is equivalent to, from 0 to pi over 2, 1/2 dx minus 1/2 cosine from 0 to pi over 2 cosine u. So du dx is just d over 2. So therefore, that's 1/4 na. So continue din aside. So that is 1/2 x from 0 to pi over 2 minus 1/4 cosine u du. Integral of cosine u du is sine u. So sine u is 2x from 0 to pi over 2. Okay, so substituting, that's 1/2 times pi over 2 minus 0 minus 1/4 times Sine 2 times pi over 2, cancel, minus 0. So sine pi is 0. 0 minus 0 is 0. 0 multiplied to 1/4 is 0. So this is disregarded. Therefore, pi over 4 is our final answer. And that is in radian form. And that is our final answer. Okay, let's proceed with the powers of tangent and cosine. So for powers of tangent and cosine, case number 1, the power of the second should be even. So if that is the case, you're going to keep isa ka second squared x, and then the remaining will be transformed into this form, then make a u substitution. So for this problem, that's from 0 to pi over 4, tan to the power of 4x, manipulate second 6x. So according to the rule, mag-iwan tayo ng second squared x. And then what's left is second to the power of 4x, right? So second squared x squared dx. So this one, kanisha is according to the rule, change the remaining seconds to this form. So that's 1 plus tan squared x squared and second squared x dx. Then the next one, what we're going to do for the next step is to use substitution. So this is u to the power of 4, then 1 plus u squared. Balik ko nag-u, no? So u is equal to tan x man, di ba? Du is equal to second squared x. Then squared. Then second squared x dx. So this is the u. Okay? So if you're going to let u substitution, guys, we are going to change the limits diri a. So para sa later part, we will not transform back to 0 to pi over 4. Ani na siya. So u is equal to tan x, right? Therefore, our upper limit is u is equal to tan pi over 4. So tan pi over 4, that's, again, your calculator should be in radian mode. That is 1. That is our upper limit. Our lower limit is tan 0. So that is 0. So therefore, our change limits now is from 0 to 1. Okay? So I will explain later nga nung inanaon man nato siya. So for that, let's continue from 0 to 1, u to the power of 4, expand 1 plus u squared to the power 1 plus u squared to the power of 2. So that is 1 plus 2u squared plus u to the power of 4 du. Okay, so that's from 0 to 1, u to the power of 4 plus 2 u to the power of 6 plus u to the power of 8 du. Okay, some of you might be confused, sir, why did the lower and upper limits have changed? Because if we are going to use x, the limits is from 0 to pi over 4, but we have used u substitution here. We have used u substitution, therefore our limits will now change from 0 to 1. So that will now be u5 over 5 plus 2u7 over 7 plus u9 over 9. That is from 0 to 1. So that's 1/5, okay, plus 2 over 7 plus 1 over 9 minus 0 over 5, 0, 0, 0, so minus 0. So therefore, we can now use our calculator, change back to degree, 1 over 5. Yeah, so that's 188 over 315. Final answer. Actually, you can use the 0 to pi over 2, but the limits, okay, 0 to pi over 4, but you should change it back to x, no? Tan to the power of 4 x, which is, sorry, dapat pag integrate nimo ani, kani siya diri na part. So, di ba, integrated na siya. So, if you're going to change it back to tan 5x over 5 plus 2 tan 7x over 7 plus tan 9x over 9, you should change it back to its original form na pi over 4. So that's the time that you use 0 to pi over the limit. So it's very convenient for us to use substitution and change the limits so that we can easily find the correct answer. And now for the last case, which is case number 2. Consider the integral of tan to the power of mx sec to the power of nx dx, where m power of tangent is add. So kaganina, ang n is even. Now karon, add na po daw ang power sa tan. So you are going to keep isa ka tangent. So for example kani, keep daw kag isa ka tangent. 0 to pi over 4, keep kag isa ka tangent. And convert the remaining tangents to seconds. So kani, 7 man na siya. So mahitabo is tan squared x cube. So 3 times 2, 6 plus 1, 7. So that is correct. Okay, what's the next step? The next step here is to change this form from 0 to pi over 4 tan x to kanina form. So tan squared x is equal to secant squared x minus 1. So that's secant squared x minus 1 to the power of 3. Then secant 5x dx. Okay, so let's use substitution one more time. So use substitution daw. So tan x. So therefore this is tan x. So mag-separate ta og sec x dx. So separate tag isa ka sec x dx at tan x dx. So ang mabilin diri sec to the power of 4 na lang. Okay. And then this one is still secant squared x minus 1 raised to the power of 3. So from 0 to pi over 4. Then pag maglet na ta og use substitution dire, mag-change na atong limit again, di ba? Mag-change na atong limit. So this one, secant squared x minus 1 is u squared minus 1. Our sec to the power of 4 is u to the power of 4. And then our sec x tan x dx is equivalent to du. So to change the limits, u is equal to secant of x. So u, ang upper limit is secant raised to the pi over 4. Ang lower limit is secant 0. So what is the result? So ang secant pi over 4, di ba secant is 1 over cos. So 1 over cos. Then dapat naka-radian again inyong calculator. Pi over 4. So this is square root of 2. Ang kani, secant of 0 is 1 over cos 0 is 1. So therefore, our new limit is from 1 to square root of 2. So let's erase this. So to rewrite this, we now have from 1 to square root of 2. So that is u squared minus 1 cube, u squared minus 1 cube, u4 du. So using the Pascal's triangle to extract u squared minus 1 to the power of 3, so you will have u to the power of 10 minus, sorry. So, sige, extract natin siya using katong ano lang na method, no? Okay, hindi na maglabad-labad. So, u squared minus 1 times u squared minus 1. So, u4 minus u squared, u4 minus u squared minus u squared plus 1. So, that's u4 minus 2u squared plus 1. Then, multiply again with u squared minus 1. So, that is u to the power of 6 minus u to the power of 4 minus 2u4. Again, you can use the Pascal's triangle para ilabad. So 2u squared. Then anabilin plus u squared. Then minus 1. So that's u to the power of 6 minus 3 u to the power of 4 plus 3u squared minus 1. So multiply it with u4. Therefore, that's u to the power of 10 minus 3u8 plus 3u6 minus u to the power of 4 du. So, multiply na nako si u4 with this. So, therefore, from 1 to 2, that's u11 over 11 minus 3u9 over 9, that's u9 over 3 plus 3u7 all over 7 minus u5 all over 5, and that is from 1 to square root of 2. So therefore, that is square root of 2, 11 over 11 minus square root of 2, 9 over 3 plus 3 square root of 2, 7 all over 7 minus square root of 2, 5 all over 5. So bracket minus. Okay, this one is easy kay 1 lang man siya. 1, 11 minus 1 over 3 plus okay, using our calculators, it will lead us to the answer of 0.3028. So let's use the 4 decimal numbers for this answer. So the next topic will be about a trigonometric substitution. So that is in another video. So thank you so much for listening. Have a nice day.